Greetings and welcome to week 4, unit 4 on taxonomy table. In the previous unit, we understood the nature of categories of engineering knowledge. Now we put it all together in this unit and we try to understand the importance of taxonomy table in achieving alignment among outcomes, assessment and instruction. It's a taxonomy table is a simple graphic tool to facilitate our designing a course or conducting a course or to achieve the right kind of alignment between various activities associated with a course. Revised Bloom's taxonomy, as we explained, is two-dimensional. It has cognitive processes or cognitive levels or knowledge categories. There are 6 cognitive processes and 4 general categories of knowledge. And courses in sciences, mathematics, humanities, social sciences, and management in engineering programs are concerned with only 4 categories of knowledge, the way at least we handle them right now. So what happens as they constitute fairly significant part of an engineering curriculum, we need to look at only 4 categories of knowledge. So a table with 6 rows of cognitive processes and 4 columns of categories of knowledge can serve as an excellent tool to deal with several issues of teaching and learning. It is a simple graphic tool. There are 6 rows of cognitive processes and 4 columns of knowledge categories. In some of the books, these kind of reversed. That is, you have 4 rows of knowledge categories and 6 columns of cognitive process. We felt we generally start with when you write anything, whether it is related to assessment, instruction, or writing an outcome, we start with the cognitive activity first. What is it that you want to do? And that's why the first one is we put it as cognitive process as rows and knowledge categories as columns. So you have a 6 by 4 kind of table. Okay, what is it that we are going to do with this? We'll presently explain. Now, a cell of the taxonomy table can be numbered by its cognitive process 1 to 6 and its knowledge category 1 to 4. So, the cell 4, 3 represents 4 is analyze, 3 is procedural. So, it represents analyze procedure, either outcome or instructional activity or assessment. Okay. So, that's how we number them. And also we accept there is a hierarchy. That is 4 comma star. That is in the 4th row, all the activities in the 4th row are more complex than the activities in the 3rd row, 2nd row and 1st row. Okay. But not necessarily more difficult. Please remember that complexity is not the same as difficulty, as we mentioned. And also a cell in the 4th row will imply all activities in 3rd, 2nd and 1st rows. What it means is, if I am talking about any activity, let's say in this cell, I don't have to again say that I am also involved with these activities in the second row and also the activities in the 1st row. It is implied. I don't have to keep repeating that. That means to apply, I need to understand, I need to remember some information. So that is implied. So if I am selecting the cell, the activities or the elements of the course related to these two cells are implied. Okay. Now we come to the next one, revised Bloom-Vincenti taxonomy table. In case of engineering courses, there are additional 4 categories of knowledge. We will call it RBV, taxonomy table. It will have 6 rows and 8 columns, because there are 4 general categories of knowledge and 4 knowledge categories specific to engineering. The features of RBV table are the same as those of RB table. That means whatever we stated now, a particular cell, depending on its location, it implies all the activities above that cell. So the revised Bloom-Vincenti taxonomy table will look like this. Same 6 cognitive processes, and you have factual, conceptual, procedural, metacognitive, general categories, and fundamental design concepts, criteria, specifications, practical constraints, design instrumentalities, the engineering categories of knowledge. So it is 6 by 8 table. Now coming to majority of engineering science courses, we already said you have science courses, humanities and social sciences, management, they all fall under only revised Bloom taxonomy table. But whereas engineering science courses like fluid mechanics, thermodynamics, electromagnetic theory, network theory, these courses can also bring in certain engineering dimension to that as well. It is not necessary to just strictly offer it as a science course. It depends on the decision by the instructor, how he wants to design the course. In most of the textbooks, in engineering science courses, like you can find a textbook on fluid mechanics, it may not look at any engineering dimension at all. It is just like any other science course, but the concepts and procedures are supposed to be useful later in engineering courses. Okay. If they do not address the 4 categories of engineering knowledge, then it is to be treated like a science course only, as far as taxonomy table is concerned. But if a teacher chooses to address some categories of engineering knowledge in his engineering science course, then you can apply the 6 by 8 RBV taxonomy table. It can be applied. Okay, but that is a choice to be made by the instructor. Now we come to what we call elements of a course. What are elements of a course? A course is defined by course outcomes. Till now, most of the people will define the course by a list of topics, maybe grouped into units, sometimes not, but as a list of topics. But as per the outcome-based education, a course has to be defined in terms of course outcomes. And they represent what the student should be able to do at the end of a course. And how do we write a course outcome? We will present it, but what should be written is to be decided by that is an academic decision to be made by the teacher. Then what happens? We need to find out at the end of the course whether the students have actually attained these outcomes. I defined all right, but did the student really learn enough to attain these outcomes? And that is generally tested by the assessment that you have. And this assessment of the course outcomes is through assignments, tests and examinations. Okay, that is the second important element of a course outcomes and assessment. Then what do? You do some instructional activities in the classroom that we have explained what is instruction, and these instructional activities should facilitate the learners in attaining the course outcomes. But attainment of course outcomes is also uh, expressed in terms of the type of assessment that you are doing. That means if I train my student in performing well in the assessment instruments that I am going to design, then he has attained the course outcomes. So, all the three are linked together. So, the three elements, we will keep repeating that. Please remember that course outcomes, assessment and instructional activities. We have the associated courses to this. There is one course on assessment and there is another course on instruction. Now, this concept of alignment is fairly old, it is not anything new. Educators always felt there should be alignment between whatever your instructional objectives, now we call them course outcomes, and the assessment and instructional activities. Assessment should be in alignment with the course outcomes. That is, I set a set of objectives, I write a set of course outcomes, but my assessment is completely at a different level. I want him to be capable of solving certain levels of problems, but I ask my questions, that is my assignments and tests are all on only definitions and explanations and so on. Then there is no alignment between the two. Then instruction should be in alignment with the assessment, because I have to instruct my student in such a way that he will be able to perform well in the assessment that I have. So, all the three elements should be in alignment with one another. So, an element of a course can be tagged by its cognitive level. We will talk about the action verb. We have mentioned the action verb earlier, but when we write the course outcomes, it will be more clear by its cognitive level and knowledge categories. Number of knowledge elements in a course outcome can be more than one. It is not restricted to only one. Based on the tagging of an element can be located in one or more cells of the taxonomy table. See, if I have multiple knowledge elements and one action verb, sometimes on some occasions we may have even more than one action verb. We'll come to that later. In that case, what happens? My tagging will put my course outcome in more than one cell, because multiple knowledge elements belong to different categories, different knowledge categories, or if I have multiple action verbs, it will also belong to multiple rows as well. And alignment among elements of course means being in the same cell of the taxonomy table. Perfect alignment means if I look at the CO or course outcome, and by tagging I put it in a cell, in one particular cell of the taxonomy table. Then I conduct instructional activities to attain that course outcome. That will also be in the same cell. Then I conduct assessment, and my questions or whatever that I ask, my assessment items are by their nature they also located in the same cell. That means I have a perfect alignment between the three elements of a course. Now, this is how one can show alignment in RBB taxonomy table. It will be similar also in RB taxonomy table. CO represents course outcome. AI represents assessment items. IA represents instructional activities. Okay. If all the items are located in the same cell, CO3, let us say, is the third course outcome. AI3, that is assessment items to test the attainment of CO3, if they are all located in the same cell. And instructional activities also can be located in the same cell. Then you have perfect alignment. But what happens is, first of all, there can be multiple cells in which the CO is located. Then I have to, my instructional activities also will have to be spread over multiple cells. Then what happens, if I have my CO3 here, sometimes I want him to, let's say, assessment items, I may want him also to kind of define something, because the definition I want to test his factual knowledge as well. In that case, it will belong to the remember category. So I may want to ask some instructional or what do you call, some assessment items belonging to a cell here, but it is relevant. So I may do that as well. Okay. In that case, it is a partial alignment. It is not 100% alignment. Now, let us look at different things here. Here, CO4 and IA4. What am I doing? CO4 is located in apply procedural cell, and my instructional activities were also in the same thing. But all my assessment items are in either remember or in understand category. This is what generally happens in quite a few of the courses. That is, my CO belongs to apply, but my assessment items, for some reason, whatever be the decision making, they either part of understand or remember. In that case, there is not proper alignment between the three elements, but it is still partial alignment which may be acceptable. Now, if you take another example, CO5 is in analyze conceptual, but my instructional activities are in the cells above. And my assessment items are also in the cells above. There is not any activity or assessment items at all in this cell. In that case, there is no alignment at all. And this is what generally happens. We write everything very nicely. We are teaching critical thinking, we are teaching analysis, and but when you look at the examination papers, all questions are related to or in the cognitive levels lower than what we intend them to be. Okay, that's what can happen. So this is a simple artifact that can be used to kind of make sure that you have the right kind of alignment. What may happen is, in the case here, if you take this, I have to put some items AI4 here also in this cell. So I have AI4 here as well as here and here. When I have it like that, the percentage weightage that I give to assessment items in this cell should be more than weightage that I give to the other cells. If I give too much weightage, then I am not emphasizing on the at the right kind of level. Okay. So one can look at it, and we will look at this in detail when we talk about how do we attain course outcomes, how do you compute that. There are a whole set of simple tools that we can make use of to do that. So the concept of alignment, if you internalize properly, then how do we make how do we attain the outcomes properly will come clear later. Okay. I hope I made myself clear through this. So course outcomes and related instructional activities should be in complete alignment. At least if these are complete in alignment, while some small percentage assessment items can be in cells representing lower cognitive levels, less than that of a CIVO, significant percentage of assessment items should be in the same cell as that of CIVO. If apply is the goal, let's say more than 50% of assessment items should be weightage, should belong to apply. That is the idea. So taxonomy table can facilitate achieving a specified alignment among the three elements of a course and eliminate any chance occurrences. We somehow do this through chances. That is, we don't systematically plan our assessment that way, saying that, okay, I will have 70% of the weightage given to a particular cognitive level. Now, these days, the accreditation procedures demand that you demonstrate that. Okay. Taxonomy table can help in the design of well-structured test item banks, and consequently the validity and reliability. These are two very important properties of assessment. They can also be achieved. I want to establish the validity of my assessment and reliability of assessment. And taxonomy table can serve as an effective tool for organizing direct or automatic intelligent tutoring if you want to go towards that. In the next week, we will try to understand the nature of affective, psychomotor, and spiritual domains of learning. And thank you for your attention.